I'm going to talk to you today about railway operations and in more detail about crew. Let me first introduce myself. Mm, I'm a civil engineer. I studied at two universities in the Netherlands, and I've been simulation research lead at NS since 4 years now. And my research is on everything with simulation. Mostly we do stochastic simulation, but most of my topics are on timetable, disruptions, and now on crew operation. So that's just a little about me. But now let's talk about trains. That's probably why you're here. So we are NS, Netherlands Railways in English. We are the biggest passenger train operator in the Netherlands. So there were more than 1 million journeys per day made on our network, which means we have 18 million inhabitants. That's 1 in 18 Dutch people take the train on an average day. So that's a very nice figure. So our passenger numbers are mostly recovered from COVID. So they are during the week, they are still a bit lower, but during the weekend they are higher. That results in 400 times around the Earth our passengers do every year with the 9 million people every year. So we're all too happy with those figures. So we've got a really nice network that covers most of the country. We are a real service provider for all of the Dutch. Hey, oh yes, haha. I made this mistake before. I had to press share, but now you should see my presentation as well. I'm sorry for the inconvenience. But let me continue. Because train operations is not just about trains. So what you need to put on a train service is you need a physical train. We call this a rolling stock or a train unit, but you also need a track, you need energy supply, but more important, you need time and space on the track. It's not like a car, of course, you cannot just turn up and go, but you have to have your allocated space in the timetable, so that the lights are coming on green as you are driving. And then, last but not least, you need a driver and a train guard on each train, which we call our crew. And that's what we're going to talk about today. So let me introduce our railway network, because I think most of you haven't been to Netherlands or haven't been on a train in the Netherlands. So what we have is we've got a railway network with very frequent passenger trains, which means you can go from Amsterdam to Utrecht, one of our biggest cities, every 10 minutes on a double-decker sleek intercity train. And our local trains almost as often to smaller places. And then in addition to that, some freight international trains. Let me show you what it looks like. So you see already here that there are many trains quite close to each other. Even when they're on time, they could be just 2 or 3 minutes apart. That's a standard headway because of the block length in the Netherlands. So this is one of our simulation models, and it just shows some trains running, some delays, some trains are on time. Just to give you an image of how many trains there are. And then to give you a bit of context. So we got this business question. Can you assess for us the impact of crew and then on crew changing trains or being on trains that are cancelled or don't reach their destination on our operational performance? So the context is that we had some severe staff shortages, mostly in 2022 and 23. Most of it's over, but we still have some shortage of mostly drivers and shunting drivers. And every year we introduce new timetables with a high number of trains, improved service, faster journeys, but they all need to happen on the same infrastructure. So let's say we improve in the number of train kilometers, but the level of infrastructure does not grow the same. So every year we need to pack more and more trains on the same infrastructure. And that means that our operations have to get tighter and tighter. So we have to get more precise, less delays. And that's why we're looking into the delays that are caused by crew operations. So then, when you're in trouble, what do? you turn to AnyLogic. So we started making an AnyLogic model. So what we did for this model, we purposely built a new model, um, and we reuse some parts and some code from other models. So we've done this since 10 years. We've developed more and more AnyLogic models, and before it was just one model, then we have the second one, third one, and now I believe we're up to 10 models already, but this is one of the larger ones. So what we try to do in this model is integrate. So we want to integrate everything about the timetable and the infrastructure and the running stock and the crew, so that we got a complete overview of what's going on the railway track. In traditional simulations, you would have just the train and the infrastructure, and then no information about rolling stock schedules or the crew plan. And this is a novelty in this model, that we are integrating all of it. So what you will see is that there is what we call a train, but it's not just one thing. It's mostly some train units and then indeed staffed with one or more drivers and guards. So we decided to model all this as agents, and that's one of the reasons why we chose AnyLogic, because we could model all these separate agents. Because you can see that if you step into the head of a driver or a train, the process is quite simple. For example, a train stops at a station, waits for passengers to board, waits for the departure time, waits for the signal to get green, then leaves, stops if there's a train in front, and then runs into the next platform, arrives, and let passengers alight again. It's quite an easy state chart that I can explain to you in a couple of words. But then we've got this for all the agents. So the drivers also have quite a simple state chart. They are driving a train, waiting for a next train, maybe on a break, or doing some other operations like local shunting duties. But the interaction between all of these agents is quite complex. So we decided to model all these simple processes in state charts in the different agents, and then make connections between them. This was quite a challenge, because where we come from in railway is we started using microscopic simulation tools that are for timetabling. So what they do, they can simulate quite exactly when a train departs at 9 a.m. and 5 seconds, when will it arrive at the next station, and which other trains will be in its path, or will be what the buffer times are between the trains, or what you can do with faster driving or slower driving. You can model different infrastructures, but there is no simulation of all the other processes going on, but they can be really important and also predictive for the performance of your whole system. But you can also understand that I talk about the complete overview and every little item we model. So we also had to read a large amount of data, and I will explain that to you in more detail. So what we also found when using AnyLogic is that we could develop the models more rapidly. For simpler questions, we've done a model in a week. For example, I'm now working on a question for cleaning, which is a simpler process than the complete train operation. So it was a fast model to develop this model. We started already a year ago, and but most of the time has been on getting data, getting the interfaces right, processing the data, validating the model. So still, the model itself in AnyLogic is also complex already, but a lot of time is being used around AnyLogic. Now, and we found that these analytic models are less data hungry than our previous microscopic models, because we don't need to model the infrastructure in every detail. As you see in this picture is just an aerial photograph of a junction. In a microscopic layout, you just see nodes and lines. But if you have to model each signal, each wire, each switch in this network, it becomes huge. So that's simpler, we can make it interactive, it's explainable to our users. So that's why we have been using AnyLogic for those questions. So how do we come from our data to the simulation model? So I had three important inputs. So it's the timetable, which train goes from which station at what time. So this is what you will see when you plan a travel in our app. It will give you a timetable. But it will also give you an image of which train is coming. So it will say, okay, you've got a double-decker train with 800 seats. So that's what we call the rolling stock schedule. The app can even give you the exact number of the train that is coming to you. It's like when you're ordering an Uber, you can see the number plate of the driver. Now you can check, is this really my train? That's all in our data as well. And then we need to have this crew plan. So at the beginning of each day or already before, every driver and every guard gets a detailed plan. Okay, you need to be on this train, at least from this track at that time. It contains these and these units. You have to uncouple, decouple, do other operations. It's all in that plan. And we had to get this data into AnyLogic. So what we did mostly for the crew plan, we used some Python scripts, which were quite convenient. And for the rest, we did our data processing in SQL Server. And then it all came together in the SQL Server database, and we imported it in AnyLogic. But that resulted in quite a big database, because also all our tasks and assignments are modeled as agents. So when we've got this train, it's one, we say, inseparable unit of rolling stock. You can only separate it in a workspace, in a working shed. So normally it will drive as a unit. We've got about 700 of those driving around on a day. I believe it's 400 intercity units and 300 sprinter units. But they perform a lot more detailed tasks. So a task is then to go from A to B and maybe even to some smaller stations in between. So already got 100,000 of these tasks. Now, same for the drivers. There are 1,000 driver duties on a day in this model. Of course, a train can drive around all day, but the driver cannot. We have to stick to our labor rules. They work for 8 hours a day, so we usually have early shifts, which can be very early, like 4 a.m., and very late shifts starting in the end of the afternoon or the evening, finishing at 2 or 3 in the morning. And they have, on the same level, they've got tasks to perform, what we call train service. And this is what our passengers actually use. Of course, when I go to work, I use the 8 o'clock train that goes from platform 11 to go to work. And that's what our passengers see. They see 2 intercity units on this platform going to my destination. So that's the last agent where we usually measure things. So we measure the outcome, and the performance is usually on this train service, because I want that my train's on time and that I have a seat. And those two are also our main KPIs that we have to report to the government, that we publish on our website. That is really the performance of NS. And we want to have the performance as high as possible so that our passengers have the best experience. So that's why we also in the simulation want to measure about the same thing, so that we really know that we are improving our operations. Maybe to explain one thing, you see here 1 and 4. That's between 1 and 4 is the number of units we can combine into one train. So our intercity trains are usually quite long. They consist of 2 6-coach units, but our sprinter trains could consist of 4 units coupled together. So that's why I wrote here 1 and 4. Then to give you some tips on things we found out during developing this model. So we are quite a fan of using these links. So you've got bidirectional agent links in AnyLogic, where you can link, in our case, the services to the trains that I talked to you about. And they work really well and quick. And they work both ways. That's nice. I like the interactive interface so that we can also interact with the simulation and say, okay, I will make a problem, a test problem, and then, for example, I cancel a train, and then this interface finds train units to replace it, and you can even click on which solution you want to accept. So we can now play real situations with the simulation. And what we've done now, we at the end of the simulation, we write our AnyLogic database to a CSV file, just a text file, so that we can read it in Power BI. And then you've got just one bunch of output files with the time and the date, and it's really traceable on what's the result of what run. So those are features we have found out building this model and we rather like. Then I want to do a little case study with you, because this is the question we've got about this robust crew operations. Can we make a crew plan more robust by allocating buffer time in the right place? So suppose I've got two trains arriving at, I've done this in real Dutch railway abbreviations, they arrive at a station called UT, which is actually Utrecht, where our headquarters are. One arrives at 10 a.m., one at 10:05. Then I've got two trains departing, one at 10:30 and one at 10:25. So suppose both options are allowed. So I can either have the train driver from the 10 a.m. arrival on the 10:30 departure or on the 10:25. So you see I made it in dark blue and in purple. If both options are feasible in terms of meal breaks, route knowledge, the driver getting home to his home base at the end of the day, which of these two options should I choose? And to be honest, I haven't got a clue, because they are both feasible. We say 20 minutes is the minimum connection time, so it cannot be below 20 minutes. But yeah, if it's 20 or 25 or 30, I don't know. So we started thinking, okay, what metrics can we think of to assess which of these solutions is better? For example, maybe one of the trains is more important in terms that there are more passengers in it, or that it goes to more destinations. It could be that one of the trains is more often late than the other. Let's say part of the network is prone to disruption. We know that most of the busier sections have more disruptions. Well, makes sense. So maybe we should add more buffer time there, but it could also be that drivers which are more and more towards the end of the shift are harder to dispatch, because they need to get home to the specific location, because that's where they live. So maybe you want some more buffer time and freedom towards the end of the shift of the driver. So that's an option, but we didn't know. So we started to find out, and we did this by historical delay data. So indeed, which trains are late and often. Then we tried to optimize the buffer times given on this, and then the solution simulated and see if the outcome punctuality, how it compares to other scenarios, and then we evaluate the robustness. So that's what we've done here. So we used our crew optimization software from our software supplier Cisco in Portugal. We're working together with them on this project, and then we made all different scenarios with different transfer times, and then we could see how they perform. So what you would see that, of course, a solution with less duties is more efficient, because we need less staff and have lower costs. So that's preferable. So we started with a scenario with only 10 minutes of transfer time, which saves us duties, of course, but will probably ruin all our operation performance. Now, we made some other scenarios, also iterative scenarios, but in general, you will see that what we would like is a plan with a low number of duties and a high buffer. So the buffer is then the time above the minimum connection time between the first and the second train that a driver has to perform. And it would be nice if the number of changes is lower, because that means if drivers have to change trains less often, that makes a more robust plan. But we see that it's more efficient to change as often as possible, because then you can shorten the transfer time. So now it is a bit of a game. There's no silver bullet yet, but it's very interesting to work on. Another thing we did is validate. Because this is a new model, we needed to validate it. So we started by, is our input correct? So we found bugs in the timetable, in the infrastructure. We are improving the quality of our crew plans. And we also validate by checking the train behavior. So when you look into it, you expect the train to drive from station A to B in that amount of time. And if you see them standing still or if there's some deadlock somewhere, we have to fix that. So that's a validation we did. An important validation we did is the output of the delays, compare them with real world data. And it's always different. So the simulation output is not exactly the same as the realization, but we can see where there are differences and explain these and try to solve them. So we see that, for example, some corridor trains are more late than in practice. We need to improve something on the modeling of the corridor. It's probably incorrect. So that's an important thing we did. And you see in the picture, it's a very simple validation, but we had some target buffer in the plan, and has that been realized? So you will see that now target buffer you see 6, 8, 10, 12, 14 minutes, and the median buffer is always higher than that. No, okay, that's a relief. That's working well. So we did this kind of checks for validation. And yeah, when do you start delivering value with your model? Because our model is now almost finished, but we've done mostly development and not so much research and demonstration with the model itself, because we still had to get the data. And we're now on the phase that we say, okay, our data is correct, we trust the model, we can use it, we can answer some questions. But we were the first train operator in the EU to model these crew operations this way and to now really attach it to the rolling stock and the timetables. That was quite special. But we also found out that some visualizations we made are already vegetable. So I made this visualization of which driver goes in what parts of the network, just for checking purposes, if it was as expected. But this is already something that wasn't there, which we delivered. So that's a nice example of how we make added value already from the start. And we improved all of these data interfaces between our planning software and our simulation, and between the different planning software. So we find also bugs in them just because we started using them. So that's a nice example of value already. Then about the future. So I put a picture here of our newest train. This is our new intercity, which will be coming to Belgium in our newest color scheme. So this will be the future train that our passengers will be able to enjoy in a couple of months, hopefully. But what are we going to do to develop in our simulation model? So we want clear output metrics. So we now compared two plans, but mostly on details. And I really want one figure that says, okay, this plan is 50 robust, and this plan is 60 robust, or say this plan is 10% more robust than the other. So something like that. We want to compare a current and a future timetable, because of course, when we validated our model on the current timetable, we have faith that it will predict a future timetable, and then we can already see weak spots, critical spots, and now bring this to operations to improve them for next year, to make them ready for next year. And there's another thing we want to do. It's about canceling trains and then seeing the impact across the network. But in general, we've now built most of the model. It's time to start using it. But then it's a matter of finding the right questions for which the model is built, but which are also relevant to your business. To give you a bit of a broader overview, this is not the only thing we do in AnyLogic. So we are 4 people in the team, and we work together on different AnyLogic models. One of our also larger questions is the placement of maintenance facilities. They have to be placed somewhere in the country. We have to have 11 or 12 of these facilities, but where? Simulation question. There's another one about the interior cleaning. So we are likely restructuring the cleaning process, but now with the simulation model, we're trying to predict how much cleaner our trains will get, how much more efficient our cleaning staff will operate. And we are doing something on the operational performance of our newest safety system. So those are, you see, it's a variety of topics, and then I didn't even mention our usual timetable, dispatching questions, which we also get a lot. So it's very nice work. We are seeing all of the railway industry in the Netherlands. We work together with other European train companies quite often. We're one of the few companies doing this sort of macroscopic modeling, so we mostly talk to them on this more detailed microscopic modeling, but it's a pleasure working with. So that's what I wanted to share with you today. And then I've got nothing more to say. I just wish you a pleasant journey. Hope to welcome you on board our trains one day. And I'd be happy to answer your questions. Let me see. Where do we start? Considering at the timetable and the crew plan, this model could be used to dimension the service in the station team. Yeah, so it's very complex to make the timetable and the plan and, for example, the number of staff we need. These are all planning questions that we answer with planning and optimization software. So this is not an outcome of the simulation, but it's usually an input. So our planning department says, okay, we have made a plan, can you evaluate it? And maybe we've made an alternative plan, can you do an evaluation on that? So it's not so much an outcome. It's about a question of Jürgen about reproducibility. Now, so I think there are two different use cases. So we've got one use case where we use the model interactively, and for example, dispatcher could hit buttons and dispatch trains, and then the outcome is knowledge and learning. But if we want the output in figures and a real evaluation in KPIs, then we will do probably stochastic Monte Carlo simulations with a number of runs that are reproducible. So that's a different use case. But indeed, your question is valid. We won't be using it in that way. And how large is the network I'm modeling? We model the whole network. So all trains in the Netherlands, all trains that are operated by us. And so we don't partition the network based on the crew districts. So our crews have a home base, but they usually travel over almost all the country. So let's say the Netherlands is 4 hours on the train from top to bottom, and they will do 8 hours in the shift. So they can do one end to the other and back. So it's really the whole network. What's the number of rows used in this project? I showed it on the slide, but maybe I didn't say it. So our largest table has got, I think, about 100,000 rows. So we handle it usually with SQL. We do the operations on it, and then we read it into AnyLogic. No, so indeed, we haven't used it for online control yet, if I'm reading the questions correctly, but for spare duties in advance. The new and the former intercity trains and 16 double-decker trains, how is our model impacted by that? So this model, not so much, because it's on trains that are driving on our network, and they might be disturbed by other factors. So we see that newer trains usually generate a bit more disturbances in the beginning, and then usually less when they are in operation for, like, say, a year or a couple of years. But we do have other simulations that are really into this. What's the effect of introducing new rolling stock? So in those models will answer this question, but in this model, there's not so much of impact. I do not use any Excel files. So we do SQL and Python, but then mostly to CSV because Excel, it's just annoying with the dots and the commas and the 1,000 separators. So we usually stick to CSV. Real time. Yeah, that would be nice. We've got quite some good APIs at the Netherlands Railway. So I've tried it once indeed to load some data, but one of the key issues in this, if you have to do it really real time, then you also need to know what happened before. So how have you come to the current state? So from the internet, I can recall, okay, which train is where at the moment, maybe which driver's on it, but I don't know what happened before. So you have to have a log of all of this. It's quite complex, but it would be very cool to have one day something we can start working on. Can I improve Train travel in Germany. Yeah, I see some solutions for this. So either we take over, so just the Netherlands Railways goes into Germany. I think the European Commission will be very happy to this, or just wait until they solve the problems. But I have to admit, I traveled in Germany for 2 times across the whole country without delay, so it might just be my luck. Um, but I'm very happy to see German train travel improved. Um, yeah, so the question about the size of the data set, the simulation slows down. So our simulation is still, for me, it's fast enough in the way that I can hit play and then I can simulate a day. I think a day takes a couple of minutes, but because it's interactive and it's visual, that's actually a nice time and it's not too slow. But I haven't tried it Monte Carlo yet, and that's the thing I will see. But we are about at a tipping point, so it's a good question of you, Mo.